All right. So hey, everyone. Thank you for joining us to talk mainframe modernization. Last session of the first day of Next, so hopefully you're not sleeping. And maybe we can even wake you up a bit, and hopefully you'll find this useful and informative. I'm David. I'm the Group Product Manager responsible for application modernization in Google. This includes mainframe, Windows, Java, and other workloads. And joining me today is a powerhouse of speakers. There's 3 topics we're going to cover today, so you get a 3-in-1 session. We have Rajesh, who leads our global mainframe practice. We have PH from SulAmérica, who is the head of platforms. They're going to share a customer story about their journey for mainframe modernization, the success that they're seeing, and also 2 incredible partners. We have Edward, the CEO of Mechanical Orchard, and we have Matteo from SoftLab, and they will come and talk about the use cases of how we can apply AI to help our customers solve their mainframe problem. So for today, there's 3 topics on the agenda. Again, packed session. Going to start talking about what's new with Google Cloud for mainframe modernization. We have a new feature available in our mainframe assessment tool around business rule extraction, which I'll present. And then we're going to present 2 different approaches for how you can use AI to modernize mainframe. An AI deterministic approach, a customer story with SulAmérica and Mechanical Orchard, and then how you can accelerate reimagine mainframe application with an AI generative approach, with Rajesh and Matteo from SoftLab taking the stage to present. So again, hopefully you're going to find this useful and helpful. So mainframe modernization for us is a multi-pattern approach. And at Google, we want to make sure that we offer you the right tools and the right capabilities for all these patterns, because it's not a one-size-fits-all problem. Some of the capabilities we offer around assessment with AI, rewrite, modernization with AI, and testing and de-risking with Duran is done through first-party products, and we have partner products that can augment our core capabilities for some of those other in-demand modernization patterns. Specifically for AI, because we're all here to talk about AI for mainframe modernization and how we can help accelerate and help our customers be successful, we think that we are the best hyperscaler because we have a fully integrated top-to-bottom stack, starting from our best-in-class AI infrastructure, research with DeepMind, models and tooling with Gemini. But also, I think what makes us unique is that we add on top of it a layer of products. These are Google products that are domain-specific, that help address the specific complexities and challenges with large-scale mainframe modernization, and amazing partners, as you'll see today, that take this entire stack and extend it even further to help our customers. From our first-party portfolio of offerings, the Google technologies around AI for mainframe modernization, we have 4 group of products that help facilitate an end-to-end journey for our customers. For assessment, we have our mainframe assessment tool, which customers can use to reverse engineer their mainframe workloads, generate documentation, untangle that spaghetti of code that is the mainframe code base. Especially useful because those mainframe applications have been around for decades. And now we're also introducing a feature which we'll show today around business rules extraction, allowing customers to distill just the business logic that's hidden within decades-old mainframe applications and use that as a stepping stone, as the first step to start forward engineering. That's assessment. For modernization, we have capabilities with Gemini CLI and a collection of agents that you will see today that help customers take the assessment outputs and then build a factory model to modernize at scale from that. Testing and de-risking, super important. We have our flagship product, Duran, which is quite unique. It lets customers test the modern application before it goes live using real mainframe traffic and data to de-risk the process, validate, and certify the modern application. And then for data migration, we have our mainframe connector that lets customers unlock mainframe data, seamlessly copy it into Google Cloud, where they can build new business functions and innovations on top of it. We also have proven results, success stories with customers across those different modernization patterns. And of course, as I mentioned, a very strong set of specialized partners that can help customers actually deliver those projects, both on the services side, partners specializing around Gen AI delivery, and partners who have products and solution that can help address some of those other patterns or also build upon what we offer with AI and extend it even further. All right. So what's new for Google Cloud Mainframe Modernization? We had another session today, just before this one, where we dove much more deeply into the mainframe assessment tool and this new feature of business rule extraction. But just at a real high level, our mainframe assessment tool, which is a GA product that you can use, allows you to reverse engineer your mainframe code base. It does multi-language analysis. It can generate automatically using AI documentation, detect domains, untangle that spaghetti of code that is mainframe modernization. But also now it can extract the business rules, which allows you to understand what is the business logic buried in your mainframe source code, which is super helpful in by itself, map the business processes, visualize them, but also uses a foundation for forward engineering. So this feature is available. We really hope you like it. Try it, and hopefully it will help you modernize even faster. Now, before I wrap up and move on to the second part of the session, I want to also touch base a bit about how we look at AI being applied to modernize mainframe applications and mainframe code bases. It's not a one-size-fits-all solution, even when we talk about AI. We primarily see two patterns that are being leveraged for different workloads, even for within the same customer. One is AI deterministic, more of the like-to-like approach, where you take mainframe code, and then through self-healing loops, you build and you test, and you generate new applications that mimic the same data flows, the same business processes, the same data structures from the code as the foundation and the starting point. And the second one is AI generative, where you use the business rules. It's a logic-first, rule-based modernization pattern when you extract the business rules and build a new application from that. We will show you both of these today to see which one, you can see which one fits your use cases better, and it's also quite common to combine both for different workloads. And putting all of it into one slide, when you look at the capabilities that I mentioned about assessment, modernization, and testing and de-risking, if you take our products, the mainframe assessment tool, Matt, our Gemini, of course, Gemini CLI, and our agent that you run together, these are at a high level the capabilities that they can give you to really do an end-to-end modernization journey. All right, and with that, Edward and PH, the floor is yours. Thank you.
All right. Well, good evening, and boa noite, Paulo. Boa noite. É prazer te la conosco.
Ótimo estar aqui.
We're going to stick to English, I think. This is Paulo from SulAmérica. He's traveled away from Brazil to be here, so thank you for traveling, and looking forward to talking tonight about our project together.
Yeah, I'm Paulo. You can call me as PH. Good evening, everyone. I'm a head of platform engineering at SulAmérica. And in platform engineering, we are responsible for a lot of topics like software engineering lifecycle and cross-domain services and initiatives together string-aligned teams, like this mainframe modernization as his internal consulting team.
Well, good to be here again. Thanks for flying in. Let's begin with a quick overview of the company, SulAmérica.
Yeah. Quick introduction about SulAmérica. We are one of the largest insurance companies in Brazil, serving about 7 million customers in 130 years of history. We operate across business lines like health, dental, and life insurance, running 24/7 in very sensitive situations, like when customers need healthcare services. And on top of that, we are very active in a very high regulated market. So we have a lot of responsibility about this technology, so it shapes all the strategy that we have.
Thank you, yeah. So an old, venerable company with mainframes.
Yeah.
Tell us about your modernization journey. How did it get started?
We have a large and complex legacy state. Some systems and programs evolved over decades. Some of them are older than me, and they are critical and they are running our core business processes. And to maintain those systems, it depends on a small number of people with a real risk of attrition, like they are retiring, for example. On the other hand, we have a lot of pressure from the business side to design and launch new products faster and need to scale them. Now, we can achieve that with cloud practices, but a mainframe becomes a bottleneck for business and speed and flexibility.
Sounds like a lot of customers we come across, these are common issues. Tell us more about the challenges you were facing in particular, though, with your project.
Sure. We have a big and complex technology stack inside mainframe. A lot of lines of code, jobs, a lot of jobs, and a huge data sets that are being processed every day. But it's not a tech challenge. We have a lot of risks that, as they are our core business rules that we need to processes. They are based on decades of hard work. So we tend to be more conservative on changes on that. Mm-hmm. So if you change something, you can break something in the chain of execution. So you cannot afford any disruption. And the knowledge of those systems lives just on few people, or just in the source code. So for this transformation for us, it's important not just to translate the source code from COBOL to Java, but we need to understand the logic and business rules that are implemented.
So the minimizing disruption, making sure you don't break something is critical to this method. And that's why it's one of the use cases David mentioned, where it's very important to understand exactly how the system works and reproduce it without making any mistakes that you didn't mean to before you start changing it. So how did you choose the first application out of those 45 million lines to address? Besides
of the risks, we selected the claims reception that is from providers. It's a part of our claims management system. As a whole, it's about 30% of our mainframe consumption. It tends to have an impact directly on our revenue also. So it's a very representative use case. And what stood out about Mechanical Orchard in this case is your approach to understand the system end-to-end across jobs, like programs and data, and as a vertical slice. So to achieve the confidence on the modernized workloads, we need to compare behavior of the new system that is implemented with the live system that is running if the output matches step by step. So the equivalence is not just a concept, but it's a way of work there for us. Mm-hmm, mm-hmm.
So it's a pretty significant application to start with. And what happened today and what have we seen so far? You've got the whole mainframe, you've got the priority application, and you've chosen a first
It's huge,
job.
right?
Yeah.
So we started with a workload, a small workload for us, but I know that it's not as small as it seems. It's 130 lines of, 1,000 of lines of COBOL across the more than 60 programs. So it's a complex ecosystem that we need to manage it. But we got the results faster than we expected. How we can achieve this to be faster? We are just not trying to implement a long-running program modernization that just to pick up the value at the end of it, but an incremental approach that delivers value in smaller batches of work, reducing the risks and the impacts of business by proving equivalence each step. So we need to be confident to be faster, and we have, for more is important to have this production ready equivalence changes.
So you found you went faster by proving the equivalence with production data at each step of the way, and that's how you addressed all of this. And let's talk a little bit about what's happening behind the scenes. So Thoughtworks is the SI in play here, helping SulAmérica. They're great partners in Mechanical Orchard. There's one right there. There's a thought worker. Hi, Simone. And the team there is using Imogen, which is the platform for mainframe modernization that Mechanical Orchard builds. Basically, Imogen recreates components one by one from the mainframe into a modern technology stack using agents. It takes a different approach than the traditional one, which is kind of the translate the code and then try and prove that it's correct. Rather, it's built on a philosophy of test first. So we're actually thinking of the test, the specifications first out of the gate, and then implementing the code and then proving the equivalence by showing that the tests are running. And this effectively solves this age-old problem that many of us have experienced in mainframe or large legacy modernization projects, which is that it's actually the lengthy verification and cutover cycles that get in the way. That long tail of work that you're never quite sure if you've really produced the system that you think you have. That can prolong and often doom these kind of projects, and we think we've broken through that with this different approach, especially when the legacy code is not well understood. So Imogen provides this kind of low-risk, test-first automated way to get to a modern code base with confidence. And how does it do that? Well, it repeatedly captures data flows in and out of the old components, again and again and again. And it sees what the code coverage is for all those different data runs for each component by running the COBOL or whatever in an emulator. And it generates synthetic data for any edge cases. And having got that, it then can pass those data flows through the candidate application that the model has created, but provide a test harness for that model, which is those data flows. So it can iterate against the correct specification and eventually hone in on an implementation that is provably correct. And that's the point, to prove equivalence. And that's why you feel going faster, because if you can prove the equivalence in every possible code execution path with real production data, right, then you know what you've got. And with confidence, you can move that component to production and then start to change it as much as you like. Right? That's the basic concept. That's a lot, so I'm going to show you a very quick video and attempt to narrate it as it goes of Imogen in action. We'll start off with the Imogen parse module, which is pulling in the millions of lines of code, summary of the system here, certain application, analyzing the different batch and JCL and kicks and data structures. There's a graphical representation of it that you may have seen something similar before of the same information, just easy to visualize the dependencies. And we can also do natural language queries on the outputs of parse, something like this, where a language model is using all the inputs it gets from parse and other sources. We can actually integrate with Google Math, for example, to enrich the information and come up with a very usable, human-readable answer. So these are very useful tools just to understand the mainframe in great depth, especially the dependencies, the code flows, the data flows, and the codes and how they interact. So that's kind of the analysis phase, but of course, what's interesting is actually the translation. So here we have the batch jobs that are under modernization. We'll click on one in particular. There's a list of the data flows that were captured, right? So now the language model has produced a candidate using those data flows as a harness, and we can see how correct they are here in the remote backtest step. So here we have some of the runs that had problems. In other words, there was a difference in the candidate implementation in the output from compared to the legacy one. We've got to go fix that with prompt engineering or just developers opening up an IDE. And here's one that was good out of the gate, right? So that's giving you a sense of all the different batch jobs, the equivalence we're doing, and the proof and the fixing if it's not totally accurate. Let's look at a kicks program instead now, rather than just batch. Here's one. You can see various information about it, the data flows that have been captured, and we'll go into look at its progress. Here are various parts of the kicks program. There's actually a screen involved in this one. Let's go look at the screen and its the various parts of it, and again, the data flows. Now, in the case of screens, we're actually taking production inputs into the UI and seeing the outputs back through the green screen and then comparing that to the web page reproduction to get the exact same inputs and outputs. So you can see that the equivalence is the key here, whether it's batch or whether it's kicks or other, and the data that's captured from production is how we prove it. And that's really the essence of it, and I think it's the confidence that gives you that's the breakthrough. You don't have to then go test and verify. You're done. Done means done, and you can put that into production and go. And in the end, the whole time cycle is way collapsed. Right? That's really the value here, and that's why we've managed to get so far with you. A word on Google integration. So this is David's slide from before, talking about the different Google tools in this domain. Imogen integrates with actually all of these quite deeply. So it works extremely well on GCP and technologies around it. For example, I mentioned that Imogen parse, that initial phase, can pull in MAT information. So if you've already run MAT, or actually other third-party tools, you can enrich the language model, the Imogen Explore language model experience. The data capture that we're doing is helped a lot by certain mainframe connector and dual run interceptors. So we're actually collecting mainframe data using some Google technology, which is helpful. And of course, the generation stage, the language model can be Gemini, and we've found great value in that. And finally, the verification loop is aided also by dual run. So Imogen is a standalone product that can work on any cloud, but it's working especially well here with these Google technologies, and we're very tight with David and Yoav and Rajesh and the Google team in general, making sure that customers like PH here has a good experience on GCP. Anyway, so what actually happened here, Paulo? What did we get done so far?
Yeah, so we have a lot of outcomes. Yeah, and we get more time on past initiatives, just trying to figure out what the code does. So, and now we have like 70% of our workloads translated to Java. So from the installation of Imogen in our cloud infrastructure to those translations, we have just 3 months. Mm-hmm. So it's small time frame if you're considering the complexity of the programs and the size of data sets. So its speed is incredible that we achieved for per week. One thing also I think I need to mention is right now we have this business documentation of all the code, so it's amazing also. So we have a lot of experimentation that we are doing together, so it's very fun thing to do. Yeah. And from my personal perspective, like I saw the code that is generated in Java. It's a true cloud-native workload, so it's not a Joball program. So it is with best practices, observable and scalable. So our expectation is to have a more predictive software, proving by execution equivalence, functional and execution equivalence.
Just to call out some of these stats, the first one's talking about the speed of the initial parsing of the mainframe code. So we're talking about many millions of lines. We have a very fast parser that can extract all the information that you saw. The installation of the product, we actually do it in the customer's target cloud so that no data or code need to leave their, in quotes, network, right? So it's secure in that way. We're very excited about this approaching 10,000 lines of code per week per person, right? That's with the automation that we have. And that's not just translated, that's actually proven equivalent in the way we discussed, right? And Imogen has got a long roadmap, and one of the main things we're working on right now is parallelization and automation with more agents of the lines of code per week. So we think that's going to go up even farther, such that you can actually imagine 1 million lines of code being put into production with strong confidence of equivalence in a matter of a few months, right, which didn't used to be the case before the last year or so. So very excited about the progress here. I think it's a good example of how to use the tool. And you want to say a word about the people involved, Paulo?
Yeah. So we have I think what is incredible is we are running as a single team. So from our side, we have this cloud guys that is very excited about new technology and so on. But we have a lot of wise people and experienced people that knows all the rules that we have here on SulAmérica, knows the business. So those are the mainframe guys, so we have a lot of respect between them. But also we have our partners, so they bring for us the best practices, a lot of experience. And then we are trying to solve real business problems. But you need the tools, the expertise, and a platform that supports to host and scale the new systems that we are translated. So then we are pretty excited to do this for all the claims management that we have.
Yeah. There's much more to do, obviously, but we think we're going to keep accelerating and with the help of Thoughtworks, go faster and faster and really get this stuff exited finally from your mainframe. So I think just to finish, we wanted to put together sort of what this all means in terms of what can be done these days. I think there's a lot of energy in the industry right now about mainframe modernization, lots of different approaches, tools. It's really exciting. I think the sense I get is people starting to believe this can actually happen after 30 years of struggle. You can have safety and speed. In fact, we think of safety as sort of the starting point. Start with tests. And if you're familiar with test-driven development, very similar concept. Test first, put the time into that. That will make you go really fast over time. You can do speed without disruption with this equivalence proof. You can retire components one by one, not in a big bang way, and eventually just reduce your MIPS, and eventually, if you want, exit the mainframe. And you need to have a really full understanding of the mainframe, not just pretty diagrams, but that natural language querying, the understanding of how the code flows, the logistics. That's really important because there's a lot of different batch and kicks interactions with data, as we all know. That's critical to analyze what's really happening. And so, in general, I'd say we are trying to productize this approach. It's not a click button. It's not a completely humanless process, probably never will be, but it definitely has a lot of success in proving equivalence and going faster and automating everything that we can. So we're excited. Thanks again, Paulo, for your support.
You're welcome.
Oh, yes, and by the way, we're going to be at the Prohibition Bar after this talk. Please come and join us, or you can come to the booths there at the bottom.
So please, Rajesh and Matteo.
Thank you. Now that's a tough act to follow, so it's very interesting what they have done. So let's see what, from a Google perspective, what we are going to do. So when we talk to a lot of customers, everybody talks to us and says, hey, we want maintainable Java code. And traditionally, the way that has been accomplished is through manual rewrite. Right? Customers have spent a lot of time rewriting this. And there are a lot of challenges with that. And I'm not going to repeat all of this. People have seen this and experienced this, right? Lack of documentation, lack of knowledge of the business rules, lack of SMEs. It's a manual process. It takes time. There's a lot of cost involved in this whole process. So what Google's approach with this is to infuse AI and automation in every step of this journey. Right? That's the main purpose, and that's how we think we can solve this problem. So next, how do we do this, and how does this work? So the first step that we do is we conduct an assessment, and as part of that, typically everybody does this, and that's where you need to really do a strategy and planning. And for that, our mainframe assessment tool is of great use. And as you heard from David, it also generates business rules. So and we'll show this in a demo next, right after this in a demo video, and I'll walk you through the steps. But at a high level, what we do here at this point is we extract the business rules from Matt in a UI for a migratable unit of work. And then the next step is for a human to validate those rules. Because as you can see, in fact, we just spoke to one of the customers, and he said when they were doing this migration, they found a lot of defects in their production code, because it was code that was not maintained for a long time. It's just been running, and they were paying a lot more commission than what was actually needed to their brokers. So that was one of the interesting use cases as to why this business rule validation helped. The next step after that is typically in a rewrite, people define target architecture. Right? I want to go to a Spring Boot. I want to go to a REST API. I want to go to an event-based algorithm system. So we have an agent that takes input of all of these things and then takes these business rules and then documents the target architecture, which is, again, can be reviewed by a human in the loop. The next step after that, typically in a rewrite, is a human creates stories and epics for a Java developer to go and do implementation. So what we have done now is we have an agent that can take what is in the PRD and the spec and the Java and the COBOL code together and create a plan. And you can provide input, right? You can provide inputs like coding standards. I want to do JDBC templates, for example. Here's the folder structure. I want to use my own frameworks. You can provide all those kind of inputs into this process. And that creates these epics and stories that you can traditionally give to a developer. Now, here is where AI has come. And it's pretty impressive what it can do, by the way. I'll be the first one to admit that I used to be a skeptic about, if you asked me about a year and a half ago or so, and there are many people here who can attest to it, that I was like, wow, man, no. But my God, it's pretty impressive, right? So we have Gemini CLI that can actually take all those stories and implement it. And in these stories, we actually have acceptance criteria. So we can generate unit test cases. We can validate whether the business rules that we given are implemented. So we have agents that do all of that. And I'll try to show you in the demo right now, right? So that's the unit test. And then after that, we have to go and integrate. So this is where we actually fit in with the end-to-end approach that David, Ned, and others talked about. We have tools that can help you do data migration, right? Once it is ready for code from an agent's perspective, you really do want to test it. You want to test it with a large volume of data, with data migration. So we have a mainframe connector, which is free, by the way, and it can actually do a great job of copying data from the mainframe to Google Cloud target databases. The next thing after that is dual run. Now, you can take all of this, and you can use dual run to de-risk the migration. So you can actually test it in parallel in production. So that's the next thing that we can do. Now, let's see how this is going to work in a video. I'm going to try to talk as much as I can in sync with the video, but I'm not sure if I'm going to do a great job. Let's see how that goes, OK? So in this, what we do is we're going to take an existing CICS application. Google has a mainframe, by the way, so I can see it's a Google-developed application. So it's a CICS application. It has COBOL transactions, DB2, VSAM, and DMS maps. We are taking this application and using agents to modify it. As you can see in this tool that we have built, you can see actually that the COBOL code does data validation, transfer type validation, and other things that it does. We can actually see all of that in this. So the first step in this whole journey is to take a migratable unit, and in this case, it's the whole application. In other cases, it might be subset. You define a workflow for application modernization. You give it the entire source code for that migratable unit. And then you say extract business rules. And at this point, we integrate with Matt and extract the extracted business rules, and we bring it in here. And you can see the business rules are in natural language. We can actually show references to the legacy code where we actually found these business rules. So you can actually see that. The next step is one of these extracted business rules. We actually also have confidence scores. The other thing that we do, which is very important, is we also get the order of the business rules. Because when you execute these, this is very important at some point in time, right? When you build a new application, the rules need to be followed. The next step that also, as you can see, we have a chat interface. So you can actually ask questions, Q&A, and actually from this chat interface, once you find an answer, you can transfer to the rule that you are actually looking at this point. So you have all those powerful capabilities built into the solution. Now, in this case, the legacy application had a defect, which we didn't realize. So actually, we were surprised, to be honest. We didn't look at it from that perspective, that Gemini actually found that. And then we were able to edit that rule and proceed. Now, this one actually talks about the next step after the business rules are validated. The next step is to actually provide target architecture. So this is the place where you can actually provide all information that you want from Spring Boot, I want to containerize it, I want a Terraform script, all of those things. So then, along with it, you can also provide information about project structure, APIs. I want to be an API-first application. I want an Angular front end. All of that goes into this PRD and the planning instructions. The next step after this is we get an agent that takes all this input and generates epics and stories. And you will see that here. And each of these stories has details as to what actually a junior Java developer can actually implement. Right? It actually gives you examples of what the DTOs are. And on the right side is the most important thing. We have acceptance criteria that dictates when I test this application, what will happen. Right? Is it actually implementing all the rules that I have said that I am doing? Now, we take that, we pass that information to Gemini CLI. Gemini CLI takes all that information, all the stories, and starts implementing. As you can see in here, it's going through all of these things. And as part of this, we can generate unit test cases. We can generate code coverage reports. We can validate if the rules are all there. You will see some of those in this thing here. And at this point, if there is issues, then the human in the loop comes in. But then also, we also have auto-healing in place in here so that we can actually fix any defects that we find. But there will be some points where not everything can be fixed automatically. There will be a point in time where a developer needs to be involved. As you can see here, it generates idiomatic code. We said API first, and I'll show you that later on where it actually says, based on Open API, we actually took the Kix backend and broke it into APIs. Now, this is the front end and the back end. And this is now ready. The code is maintainable. Anybody who is a good Java developer will be easily able to take this take this code and maintain it. Now, this is the APIs that I talked about. These are all the Kix transaction was not just a wrapper, right? We actually broke it into APIs that you can actually test, for example, using Swagger and expose it. Now, this is how the new application looks like. As you can see, from the green screen, we went to this. This is deployed in Cloud Run in a containerized environment. So we can go very fast when we're doing these modernizations. That's what this is. Now, I'm going to hand it over to Matteo so that he can actually talk about what he has and how they used this process in their project. Matteo, over to you.
So thanks, Rajesh. Hi, everybody. I'm Matteo Longo, Cloud Solution Practice Leader at SoftLab, a Google Cloud Premier Partner. As Raj was saying before, the theory behind the AI-driven rewrite is very powerful. But what happened when we try to move it to the real world? The number on the slide tells the story of one of our customers, a major Italian insurance company, that is running its entire claim system in COBOL. We are speaking of 4 million line of code and more than 2,000 COBOL programs. And the problems that this customer is experiencing are the same that many of you know very well, starting from shrinking COBOL talent pool to rising infrastructure and license cost, but also the newly AI-driven features that are nearly impossible to integrate, but also the knowledge that is trapped inside the head of a few people that are now retiring. So we are moving from something that could be a nice-to-have modernization to a business continuity problem. And our customer goal was very clear. They want to rewrite COBOL into a cloud-native and maintainable code. So when we started working with them, we first explored several coding agents, but we hit some real challenges. This because LLM and coding agents are very powerful if applied to a small code base, but when you try to scale, it's very complex. So we understand that we didn't need another solution, but we needed a partner. And for this reason, we joined forces with Raj's team from Google Cloud Mainframe Modernization Practice. In order to prove this, we set up a POC with the customer with a scope that needs to be representative and challenging. So we took 250 programs with more or less 300K line of code. And in the slide, you can see one of the example code chain complexity graph of just one module that is inside the scope of the POC. And here you can see what mainframe reality really looks like. Because in just one module, we have found 730 call relationship. And also, this is one of the examples that we tried to rewrite with a coding agent, but we failed. In this POC, we found several challenges, starting from massive interdependencies, because the code was deeply interconnected with shared copybook, common routines. Also, the legacy system was using XML as input-output with some complex structure. And the I/O isolation were strictly interconnected into the business logic. So we needed to isolate them before any rewrite could begin. And also, the COBOL monolith needs to be broken down into several small cloud-native services. And in order to do this, we need a paradigm shift. So together with Google, we treat AI not as a code translator, but we built an agentic process-driven approach based on mainframe modernization agents that Raj showed before, with always the human in the loop. And here in the slide, you can see an example of the business rule extraction interface, where you can have all the business rule list, and going into the detail of each rule is traced back to the source COBOL with a confidence score and some other metadata in order to have the customer subject matter expert validate the logic in natural language. And the important things here is that we are not generating code and hoping that it will work in production, but we are generating the knowledge, validating the knowledge, and generating the code from that validated knowledge. In the POC that we have made with a joint team from SoftLab and Google Cloud PSO, we set up a structured approach that is the engine of our modernization factory. If you take a look to the graph, you can see that everything starts with the discovery phase, where mainframe source code is analyzed using mainframe assessment tool in order to define bounded context and decompose the application into submodules. Then we have the business rule extraction from mainframe assessment tool in natural language. And after that, we set up some workshop with the customer in order to validate the logic and define the target architecture for the modernized application. In the subsequent step, we had the PRD generation and implementation planning, where using mainframe modernization agents, epics and story are implemented. And these epics and stories are used from Gemini CLI to generate the modernized code. In the last phase, the testing phase, after generating the testing case from the legacy environment, we have set up a self-healing build and test loop where agent can compare the output from the legacy environment and from the modernized one, identify divergences, and iterate until we reach functional equivalence. So in 12 weeks, we were able to rewrite 300K line of code from COBOL to Java with both batch and online procedure, with 100% of functional equivalence and an estimated 60% of effort saving compared to a traditional manual rewrite. These numbers are interesting, but what's really interesting is what we were able to unlock, because we unlock knowledge inside the customer. The logic of the application is now written into the business rule, reducing key person risk because business rules are documented, reviewable, and traceable. We went also beyond a simple translation because we were able to generate a cloud-native and scalable architecture with also some modern pattern inside. And on the business value, we can have a faster time to market, a lower TCO, and a stakeholder alignment that it's based on the fact that with the business rule, every line of code is traced back to the documentation in order to have everything traceable. So this POC showed to us that technology is no longer a barrier. Mainframe rewriting is something that is possible and something that is measurable. And today is no longer a question of if I need to migrate or not, but when I want to unlock this power. And together with Google, we are now working in order to propose to the customer a joint roadmap in order to extend the POC approach to the full code base that we, in a migration project that we hope we can start in the next few months. So thank you for the attention. And here in the slide, you can see a QR code where you can get all the documentation. And maybe I can go back to David for the conclusion.
Thank you so much for the presentation. Right, so thank you, everyone. Hope you found this informative. You've seen two different ways to apply AI to solve the mainframe problem: code to code, deterministic, and through business logic first, business rules to modernization to code, right? I think we have a few minutes before we are getting formally kicked out of the room. Is there any questions, maybe? And if not, we can always connect after the session itself. See, people are shy or tired. It's been a long day. There's so many parties tonight, I hope, right? Events to attend. Okay? So thank you, everyone. Hope you found it informative. And let's modernize some mainframes together. Thank you.